And here we go. So for today, it's Law of Cosines Day 2, and I'm going to use this as like the beginning of the review. And we'll also be doing some areas of triangles and that kind of stuff. So right off the bat, let's talk about this. Remember, I gave you the law of sines upside down from that before. When would you use it this way? When you what? Give everybody a chance to think for a second. There's a reason to use it this way, where the letters are on top, the little letters. Kira. When you're trying to find one of the little letters, the sides. And the other way, if you're trying to find the angles. So the thing you want to find, have that on top in the formula. It just saves you 2 steps, which, hey, that's a lot of work. Okay, now you learned yesterday how to find the area of a triangle with that new formula. If you remember it, write it down. It doesn't involve height, not 1/2 base times height. If you don't remember it, get ready to write it down. You definitely need to know how to find the area of a triangle. Okay, did you say that the area was 1/2 base times height? No, that would only work in a what kind of a triangle? A right triangle. Good. So it's not that. But it's kind of got some of the similar elements. It's got an A and a B, which is kind of like, the base and the height. 1/2 AB. But then it's got sine of C. Raise your hand if you knew that one. 1/2 AB sine C. Okay. You didn't know that one, write it down. You got to know that one. All right. So, next up, I would like to give you some sides and an angle and see if you can figure it out. So let's say that this angle, to me, it looks like it's about 50 degrees. And let's say that this side right here is 6. And let's say that this side right here is 8. I think you could find the area of that triangle then. That looked like a B there, so I'm going to change it. It's a 6. In a moment, I'm going to ask you to compare your answer with the kid sitting next to you. Remember that the person next to you, you should know their name by now. If you don't, ask them again today, and it's okay. People behind you are your partners today. Okay. For you guys, it's going to be straight across. Don't forget Jacob in the back. For you guys, it's the people next to you. Why don't you guys do long distance? And you two compare here. And you three compare. Okay. Use calculator. Yes. If you need to borrow one of mine, give me something good. Shoe, cell phone. Very common nowadays to get a set of headphones. Card keys work. Yes, sure. Compare with the kid next to you. Please check and see if you get the same answer as them. Okay. I see some people that are like arguing about how it could be done, and I'm just going to clarify. All you have to do is go 0.5 times A, which doesn't matter if it's 6 or 8. I'm going to use 6. B is 8. Sine of 50. And what did you get for that answer, Nola?
I did it
Okay, no problem. I'll call on somebody else. Catherine, how about you?
I got 18.3 by units.
I'm going to round it to 18.4. Would that be correct if I rounded to the tenths place?
Yeah.
Okay, raise your hand if you had something close to 18.4. All right. Any questions about that? All right, how about this? If I gave you the area, would you be able to work backwards and figure out one of the sides? So like if I didn't tell you that this was 8, if I just didn't say that, but I told you that the area was 18.4, do you get you'd be able to work backwards and figure out one of the sides? Yeah, you just use this formula, stick everything in it that you know, and you'd know the area, so it wouldn't be that hard to work backwards. All right, next. Law of cosines. It works when you know 3 sides and you can find an angle. I want you to compare this kind of problem where it's a right triangle and you know 2 of the sides. Let's say this is, the classic 3, 4, 5 triangle, but I'm just going to use those 2. And I want you to figure out that area. Hint, you're going to set up sine, cosine, or tangent of this angle theta, and you'll be able to figure out that angle. Don't use the law of sines or the law of cosines at this point, because you don't need to, and this is a much simpler way to do it. To find that angle, you'll have to use an inverse something or other when you're done. But start by writing out the equation. Sine, cosine, or tangent of theta. You should know by which sides I gave you. Remember, it is a right triangle. Most of our tests is going to be about not right triangles. Be honest, how many of you would like more review on this topic? All right, then you probably got it. Tangent of theta, right? No. Tangent would be TOA. That'd be opposite over adjacent. We don't have the opposite in the adjacent, so we didn't probably use tangent. What did you use? Let's go with Oscar.
I used cosine.
Cosine of theta equaled what?
3 over 5.
And then how'd you solve it?
Just did like inverse cosine to both sides.
Inverse cosine. So that cancels that. Inverse cosine of 3/5. That would be the exact answer. And did you get a decimal for it by chance?
Yeah, I got 53.13 degrees.
If I rounded it to 53.1, does that seem reasonable? Raise your hand if you had 53.1. Okay, good. Now, how would this be different if this wasn't a right triangle? Then you couldn't use cosine. This only works if it's a right triangle. So what could you use? What if I said this is not a 90? This is like a 94 degree angle. Now how big is the angle? Figure it out. Hint, you know all 3 angles. You might think you only know 2, but you know. You'll be able to find all 3 angles. Sometimes you use the law of sines, sometimes you use the law of cosines. Joe, what are you using this time?
Sine.
I agree, law of sines. And you always want to put the thing you're trying to find on the top. So, which way did you do your law of sines? Didn't you put that over something? for the law of sines, don't you?
Over 4.
Kind of have to. Okay. All right. Oh, you knew this side was 4. Interesting. But it's not 4 because it's not a 90, a 30, 60, 90. Sorry. It's not a 90-degree triangle. It's not a right triangle. So that is not 4. So, okay. So sine of some angle. How about we get the letters straight? What letter should you pick for that spot right there? Let's use A, B, and C because our formula is in A, B, and C, right? So what should you pick for that angle? When it's not a 90 and not a right triangle, you should have your key angle be C. All right, and that makes this side over here little c. And then, Joe, you get to pick. Do you want 5 to be A or 3 to be A? Don't care. All right, so this will be A and this will be A. And then that leaves this to be B and this is little b. Okay. Now would you proceed with the whole sine? Because we're doing the law of sines. You were right on that. So we're just trying to straighten out which variables we use. Sine of what over what?
Sine of theta over c.
All right. Now you switched from c to theta. And if you do that, the problem is you have two variables. You can't solve it if you have a variable on top and a variable on the bottom. So that's not going to work. Hint, Joe, look for the one that has a angle and the side across from it. That's the good combo that you want to use right now. I'll take you off the hot seat, but just pay attention here. What's the angle on the side that we know? Charlotte, do you know?
53.1.
No, that's gone now. If you guys were going under the assumption that 53.1 is still in the problem, I apologize. I changed the problem, so it's not a right triangle anymore. So that is not 53.1 anymore. All right. I'm going to go with Anna McKinney. What do you think?
Sine of 94 over 5.
Yes. Why did we pick that one, Anna?
Because it has the angle and the side opposite.
Yes. If you always start with that when you're doing the law of sines. Okay. Now we can get, well, right off the bat, we have to go with the only other side we have, which is that 3 there. So we're going to have to do sine of b over 3. And the thing that's annoying you, I'm sure, is that we aren't solving for c. But do you get, as soon as we have b, that we'll be able to get c super easy because we'll just add up to 180. Okay, so this is what you had to set up. That's the only way, as far as I know, the only way you could have done it with the law of sines. Does that make sense to you guys? All right. So then I'm going to multiply both sides by 3. And then this 3 will cancel off. And I'm going to do inverse sine of all that. And we're going to go with Isaac. What did you get on that one?
I got
How about this? Have you? I get the feeling you haven't done it yet. Just go ahead and do it, and I'll race you, and we'll see if you get it first or if I get it first.
I think I got 36.8.
And you might have beaten me there. Second answer. I got 0.598 over here. Did anybody else get 0.598 as a part of solving this problem?
Yeah, then just inverse sine it.
Right. So that right there is 0.598. And so then from there, you inverse sine that and you get something completely different than what you just said. Okay, so I'm going to go inverse sine now on both sides. Inverse sine of 0.598. And I got 53.23. Can anybody else get 53?
I also got 36.8.
Oh, interesting. Are you getting the final answer or are you getting just what B is?
What B is?
Inverse, oh, I inverse cosigned it. Sorry about that. I inverse cosigned it. Inverse sine of 0.598. All it takes is cosine instead of sine. You guys are right. 36.7 degrees. 36.7 degrees. And then why is that not the final answer to the question? That is angle B. And then I have to take that away from 180. So final answer would be 180 minus that answer we just got, minus 94, and you get 49.3 for the final answer to the question. Okay. That took a long time. I want to do another one like that just to make sure you guys are able to do that. I had like 3 people start the problem wrong, so let's see if you guys can do it now. What if this side's 12, this angle's unknown, this side's 6, and this angle is 100. I'd like you to figure out, if I call this C, I call this A, and this B, I'd like you to figure out angle A. Okay, give that one a shot. Use sine, cosine, or solve law of sines, law of cosines. There is no law of tangents that we use anyways. McDougal, tell me something you're setting up.
I set it up as sine 100 over 12, and then sine A over 6.
You did it right, sir. If you're going to solve this, you times both sides by 6. And then if you can put that in the calculator, I personally would do 6 over 12 as 1/2, so, you know, like this part. So I do 0.5 times sine 100. And then I take inverse sine of that. Raise your hand if you had 29.5. All right, awesome. So if I had then asked you for what B was, it would have been easy because these two together tell you what the third one must be because they add up to 180. All right. I think that's enough for now on that stuff. So this is one of those indeterminate case problems where they're saying prove that this is the indeterminate case by finding whatever you'd need to find to prove that that is the indeterminate case. Now, if you don't know what I'm talking about, then maybe just do part B, which is find the measure of angle B. And there's 2 B's. There's this one and there's this one. And these are both the same thing. If it's not clear, which it isn't, I'd like you to also figure out that one, the blue one. So figure out all those angles. And if you had to prove to somebody that it has 2 triangles, I would maybe do one more thing. I'm going to pause for a second while you give this a try. Okay, so find the measure of angle B. Well, I would just think maybe you'd use law of sines because I got angles and a side across from them. Here's an angle, here's a side across from it, so I go sine 33 over 6 is equal to sine of B, whichever one it is, over 10. Then I times by 10 on both sides. And then I'd have 10 over 6. It's kind of dumb to reduce this because I'm just going to use the calculator, so I'm not going to reduce it. Try to be smart about it. 10 times sine 33. And then divide that by 6. And I got 65.9077. Does that ring a bell for you guys? Did you get that as part of the problem? Okay, good. Then I'm going to do inverse sine of that answer. And anybody who rounded it off too far, your answer would be off a little bit. But mine should be pretty accurate because I used second answer to bring that whole decimal in there. And I'm going to say it's 65.2 degrees is B. And if you look at this triangle, that can't be this one. It has to be this one. And it has to be this one then, because triangles that have the same side, they'll have the same angles across from them. Those both have to be 65.2. And then if I take 180 minus that, second answer, I get 114 for this guy. 114.8. Raise your hand if you had the same thing. Cool. What one other thing could I find that would make it very clear that this had two possible triangles? Tyler.
Measure the side of your right triangle.
Yes, this side here, I'm going to make it red. This side right there. Did you find that, Tyler?
Yeah,
What was it?
5.45.
5.45. And if you're bigger than 5.45, but less than, what? 10. If it's between 5.45 and 10, it will be the indeterminate case. It will be the unknown which way the triangle goes. It'll be two triangles. You can either swing it this way, or you can swing it that way if it's bigger than 5.45. All right, cool. Let's move to this page. Which of these could be solved with the law of sines? The first one, the second one, or the third one as we read from left to right. Put it up on your hand. Put it up on your hand. And you guys are correct. It is the third one. Okay, so this one can be solved with the law of sines because you have an angle and side across from it. Which of these can be solved with the law of cosines? All of them. All of them. So you might feel like that middle one, you've only got sides that somehow, like you can't do anything with that. You can. You can do all of them with the law of cosines. All right, how about the areas? Which of these is set up to get the area super quickly? 1, 2, or 3? 1 is correct. This one's set up to do it super quickly because it's 1/2 AB sine of C. And if you've got the side angle side situation, the sandwich I like to call it, then you've got angle C, and these are A and B. So that works really slick. Could you find enough info on the other ones to eventually do that? Yeah, because you could figure out this angle here, for instance, and then you'd have a side angle side situation. And you could do that with the law of cosines. So with the law of cosines and this area formula, you could find the area of an angle. Okay. Cool. Let's go to this pink page. Everybody find side BC. Pause for a sec, we'll give that a shot. Okay, this is the part where I want you to just talk about the setup that you started with the person next to you. Would you zoom in on the setup you did, like this over this equals that over that, or maybe you did law of cosines or something? Talk to them. Okay, now what's the key about the letters in the problem? Did you even notice that you have to do something with the letters? Oh my goodness, maybe you guys all failed this question because this cannot be A. This cannot be A. Why can't it be A? Because when you're doing the law of cosines, you only have C. Okay, so you have to change that A to a C. And then this C obviously you can't have two C's in the problem. So you may change that to an A. Now I know that might seem like, what, you can just change the letters? Yes, you have to change the letters. Otherwise, how are you going to do cosine of C if it's not C? Okay, so now A is really 28 squared plus B squared, which is 17 squared, minus 2 times 17 times 28 times cosine of 91 equals C squared. And you will be finding C because that's BC. BC is really this over here, which we can call C. All right, and then save me a whole bunch of math here, please. What'd you get for your final answer? Yes, ma'am.
32.5.
Anybody verify 32.5? Oh, well, there's a couple people. All right, who's got an answer that's different than that? What do you say, sir?
33.01.
Anybody verify 333.01? A lot more hands are going up on that one. So now it is disturbing to me because, you know, like I've done it too. You just have to mess up one thing as you enter it here, and you're going to lose all the points. So really got to be careful. If you did the 28 squared wrong, or if you did the 17 squared wrong, or if you're adding them together and did it wrong, type one wrong key. This is all something you should do. And if I were you, I'd be careful because you may note there was a lot of kids that had different answers on this question. Okay, so I'm just going to do this real quick. 28 squared plus 17 squared is 1073. To see where, if you did make a mistake, see where it was. Minus 2 times 17 times 28 times cosine of 91. And I got negative 16.61. And my guess is some of you goofed up the double negative, forgot to change that to plus. And then at the end, you have to do a square root. Okay, any other questions? If you made a mistake, who found their mistake? What did you do wrong?
I put 20 instead of 21.
Oh, all it takes is typing one number wrong. Okay, let's move on. So the moral of the story of that last problem was you got to make sure that you have the letters right. In this case, are the letters right? Well, the first thing you ask yourself is it a right triangle? Does that look like a right triangle to you? No. So then, am I going to use the law of cosines on it? Yeah. I'm going to use the law of cosines on it because you can't use the law of sines. Why not? Why can't I use the law of sines? No angles. Got to have an angle. Got to have an angle inside across from it. So if I'm going to use the law of cosines, there's two kinds of kids on this. There's the kids that are going to say, okay, I'll just use the law of cosines, and they'll have to do it twice because the first time they'll find this angle that they didn't really want. Do you get? If you're doing the law of cosines and you really want angle A, then you should change it to the key angle and make it C. See what I'm saying there? Otherwise, you're going to have to do the whole law of cosines and find this angle, and then you'll be able to use the law of sines, and it'll take you 2 steps. Instead, just change the letters. I'm going to make that A into C, but then I better not have a C here also. Make that A. And now I can do the law of cosines on it as it is. Okay, 15-minute warning. I'll wrap it up here soon. Okay, thanks for the second. I was just sending directions to how to change the test because that made me think of something about how our test is worded. So, okay, Jack Taddy, how'd you set this thing up?
It is off.
So about 137 degrees on that last one, and I just directed the kids to start the Schoology quiz that's in the notebook for today, and then tomorrow is about either reviewing for the test and taking the test the next day, or tomorrow's about doing some more of the tricky problems involving area, and the next day's review, and the next day's the test. So I'll tell you for sure tomorrow whether we're testing on Thursday or Friday.